For question 13, we were supposed to solve clicker questions. So for clicker questions, this one is for, that one was for chapter 1. A radio-controlled model car moves 3 meters in one direction and then 5 meters in another direction. The car's resultant displacement could have a magnitude as small as. So we know that car moved 5 meters in one direction and then 3 meters in another direction. So we just need to find this part. So how to find it? We're just gonna solve 5 meters minus 3 meters will be 2 meters, which is answer C. Moving to the next question of the chapter 1, we have which of the vectors A for E represents the vector sum of vectors 1 and 2. Let's redraw vectors 1 and 2. So if we consider vector 1 is this one, and vector 2, we can draw it so that it starts from here. Vector 2 will be something like that. And now what we need to do is just connect these 2 points, which will give us the sum of these 2 vectors. So if this is the sum and we compare this sum to all of these vectors, we can see that vector A has the same direction as this sum right here. So vector A is the answer. Now we are moving to the chapter 2. And the question is, the figure shows X versus T graphs for 4 cars, A through D, moving on a straight road. The X-axis is aligned with the road. Decide which car, if any, satisfies each of the following questions. Choose E if none of the cars satisfies the equation. So which car reverses the direction? We can see here that we have 4 cars, but reverses the direction means it's gonna go forward and then it will go back, right? So none of these cars reverse the direction. So E, none of the above, will be the answer here. Moving to next question. So I skipped this one because this is the answer. Let's move to the next question. Which car is slowing down? If we're gonna look at the picture, we can see that this car, it stays on the same, let's say here is 5 meters, right? So each second car stays at 5 meters. So it's not slowing down. If we look at car A, we can see that every second the speed increases, which means the car is not slowing down. If we look at C, ABC, we can see that the line goes upwards. That means that the speed direction increases every time with every second, which is not going to slow down. For vector D, it is also not the answer because the car is moving negative direction, but they are asking which one is slows down. So it might be this one, but further we will see another type of question which D will be the answer for. So here it's also E, meaning that the car is not slowing down. Going to the next question, which car is speeding up? If we're gonna look at all the cars and how I already discussed in the last slide, A is the one which is speeds up because you can see that every time, with every second, this object increases its with every second the position increases, which means that the car is going faster. For the next question, which car is not moving? I also already discussed it. So B, since it always stays at 5 meters, let's say, it's not moving. Which car moves in the X direction? So I already said that we will have this question, and here D is the answer, since you can see that line is going downwards and X is decreasing, right? So it meaning that it's moving in the negative X direction. Next question, which car reverses direction? So this question was actually the first one when we chose E, but now we have one more new line, which is A here. So this object will reverse the direction because it first went up and then it started going down. So the answer here is A. Looking at the next question, there are 100 kilometers from point A to B along a straight highway. We have two trips. One is from A to B, half of way object is moving with the velocity 55 kilometers per hour, and remaining part of the trip it's moving with the 25 kilometers per hour. And when it returns, again, it moves half of time at 55 kilometers per hour and remaining at 25 kilometers per hour. So we should find which trip takes more time, first, second, or they take the same amount of time. We know that distance equals velocity times time. So if we want to find time, we need to divide distance by velocity. So we know that object moved 50 kilometers, right, halfway, and we need to divide it by 55 kilometers per hour. Let me divide it. So we get 0.9 hours since kilometers cancels out. So this is the first part, and the second part remaining at 25 kilometers per hour. So the other 50 kilometers which are left, we need to divide by 25 kilometers per hour, and we will get 2 hours, right? So in total, this object will spend 2.9 hours. Let me highlight it. All right, for the second trip, we know that return half of time at 55 kilometers per hour, remaining at 25 kilometers per hour. So let's say that half of time here, one half of t, and one half of t here, right? So it will give us 1/2 times velocity, right? Times velocity will give us distance. Kilometers per hour plus 1/2 t times 25 kilometers per hour, and we know that the object traveled 100 kilometers, right? So now we just need to solve for t. Will be 2t/2 55 plus 25 equals 100. Now we can do t/2 equals 100 divided by 55 plus 25 is 80. t/2 is equals 10/8, and now we can say that t equals 20/8, right? So t equals 20 divided by 8, 2.5 hours. So this second trip took 2.5 hours. So first trip obviously took more time. So trip 1 here takes more time than trip 2. Going to the next question. When you brake on dry pavement, your maximum acceleration is about 3 times greater than when you brake on wet pavement. For a given initial speed, how does your stopping distance x dry on dry pavement compare with your stopping distance x wet on the wet pavement? Pavement. So if we know that on dry pavement, your maximum acceleration is about 3 times greater. So that means that x dry is already greater. So to make them equal, we need to multiply 1/3 times wet pavement, right? So this is answer A. It will give us answer A right here. For this question, we have a car which needs 0.7 seconds to react to any change on the road, and acceleration when it presses the brakes is 12 feet per second square. And also we have two parts of this question. A, car moves with the initial velocity of 15 miles per hour, and part B, car moves with the velocity of 55 miles per hour. And we need to find the distance which car will travel after it sees the signal to stop. So to find the distance, first of all, we need to, so let's say car starts going from here, right? It goes some meters, so it sees the light right here, right? It sees the stop signal when it's here, but it takes it 0.7 seconds to react. So it takes 0.7 seconds when it reaches here, and from here car starts to brake, but it still goes, right? So the initial here is 15 meters per second, here it's still 15 meters per second, and here it goes down, and here the final is equal 0, right? It should stop. So here some of the calculations are already given to us. So we know that for the first part, A is 0, right? Since the car is traveling, it's not speeding up or slows down. The initial is already calculated. So, sorry, it was miles per hour, but in meters per second, it's going to be 6.7 meters per second. And T 0.7, here's the same thing, 6.7 meters per second. All right. But at the second part, right here, acceleration is already 3.7 meters per second square. The final, as I said, 0 meters per second. And B initial is the same. I also already said that. So to find the whole distance traveled, we need to find first x1, which is this, and x2, which is this, and then make a sum, and we'll get the whole distance. So to find the distance, what we usually need is we just need to calculate V initial minus, it's right here, V initial minus V final divided by 2A, where A is acceleration, right? So when the car goes with the constant speed, we do not have acceleration. So which formula we're going to use for the first part is this: distance equals speed times time. So for first part, it's going to stay the same for A and B. So it's going to be distance equal 6.7 meters per second times time is 0.7 seconds. When we multiply it, we get 4.69 meters. X1 equals 4.69 meters. And it's going to stay the same as I said for A and B. But for second part, we need to use this formula since we already have A. So we know that we need to find distance. Let's see, first part A. We know that V initial, let me see, V initial is 15 meters per second, or 6.7 meters per second, right? Square, I'm gonna remove this, square, minus V final is 0, divided by 2A, and acceleration is 3.7. So we won't have this 0, we'll just have 6.7 square equals 44 times 89 divided by 7.4, which will give us 6 meters. And now we can just add 4.69 plus 6, and we'll get 10.69 meters for the A part, for this. Now initial velocity is 55 miles per hour, and we need to translate it to meters per second. Alright, so here instead of 6.7, we'll have 24.59 meters per second, or 24.6 meters per second. So part B, we have distance. Initial speed will be 24.6 square. I'm not going to include V final because it's still going to be 0 as here. So I'll just write divided by 2A. But 2A is going to be the same as it was in first part. So it's going to be 2 times 3.7 or 7.4. Now we calculate it. We get 0.8 meters. So it's going to be 81.8 plus 469. which will give us 86.49 meters. For part B. For clicker questions for chapter 3, you threw a ball horizontally off a roof. Assuming the ball behaves as an ideal projectile, the time until it lands is determined only by. So, if we look at it, we're on the roof and throwing horizontally is talking, right? A ball, I mean. Assuming the ball behaves as ideal projectile, the time until it lands is determined only by. So initial speed, no, right? Because the speed is gonna change, so it doesn't really affect. Its horizontal distance to the point where it lands. Maybe I would go to the next. See, its final speed. Final speed also doesn't really affect, right? Because it's already at the end. So how does it affect? The ball, it doesn't. So the height of the roof. So this is honestly the most important because I think because we are throwing the ball from the roof, so we already are away from the land. So even though it's gonna go horizontally, we are still waiting for the ball to land. So that is why D will be the answer. For the next question, you and friend throw two rocks off a bridge. Your friend throws yours with an initial direction 30 degrees below the horizontal. You throw yours with the same initial speed, but in a direction 30 above the horizontal. When the two rocks hit the water, your friend is moving faster, yours is moving faster, they are moving at the same speed. So they are asking only about speed. And here it says you throw yours with the same initial speed, right? So they are moving with the same speed.